Hi, Assalamualaikum. My name is Aina Nadia binti Muhammad Safi, and we are from Group 12. We will present about a multifunction bicycle accessory for project additive manufacturing. Okay, let me start from the introduction. As we know, bicycle is a transportation that is usually used uh, by the community, and cycling is one of the outdoor sport that is gained so much attention. The mobile phone, that also known as a device, can be used to get information, to navigation, communicate, and many other things in just a second. Okay, the objective of this project is to analyze the sustainability of the product itself and to investigate the suitable of 3D printing machine of the output product, and the last one is to design a multi-functioning bicycle accessories. Next, the problem statement for this project is during cycling, it is difficult to see the path or the way during cycling activity while looking at the device. And the second thing is it is difficult to grab the water bottle and place it back while cycling. The scope for this project is to focus on the product of multi-functioning bicycle accessory which can hold the cell phone, a bottle, and hanging an item that is friendly user to everyone. And the next one is to analyze the sustainability of the product by comparing three types of 3D printing machine, which are fused deposition modeling (FDM), stereolithography (SLA), and selective laser sintering (SLS).
Assalamualaikum. My name is Hazmi. I'm going to explain about the literature review for our selective method, which is selective laser sintering, aka SLS. First, for its advantage, it doesn't have any support structure, which means when printing is being developed, all hollow space are immediately filled with unused powder along self-supporting SLS print, which means this method will be independent. The second one was fast, where since the nanopowder used in SLS needs only very brief laser exposure to be sintered, SLS printing can be one of the fastest 3D printing technique, much faster than the impressively quick SLA. Third, it has a better layer addition, where SLS printing results in very strong layer addition prints. Therefore, SLS prints have virtually isotropic mechanical properties. For its disadvantage, it is very porous and brittle, while SLS prints have comparable tensile strength compared to SLA prints, they are much less resilient and can be deformed before failure. Second disadvantage, it is prone to shrinkage and warping, where the nylon powder must be subject to a high temperature to enable sintering, meaning that the printed content will experience a cooling process almost immediately after the solid layer has developed. Third one, it produces a lot of waste, where somehow SLA printing looks like SLS printing. SLA printing utilizes an ultraviolet wave polymerized liquid resin solution instead of nylon material like SLS, while SLA liquid resin is a little pricey. The silver lining is that any leftover resin can still be reused. I'll pass the baton to my groupmate for the next part. Thank you.
Assalamualaikum. I'm Ilyas bin Zainal. Thank you, Norazmi, for your short brief. Okay, I will continue about the methodology. First of all, our team sketched new design of the new bicycle accessories. Then, we approached several cyclists and conduct some interviews with them regarding about the design of the old bicycle accessories that are available in the market. After that, we done the second interview with them. But what different is, we show them the new design of our bicycle accessories. After that, all the data were collected and have been interpreted. Then, the new design that have been approved were properly drawn in CATIA modeling. As for 3D printing machine, there are a lot of them in the market, but we only focus on 3 of them, which are fused deposition modeling, FDM, stereolithography, SLA, and selective laser sintering, SLS. Some scoring and screening were done toward these 3 machines with various criteria including the resolution, accuracy, surface finish, complexity, and cost. The final score were collected and SLS will be chosen to print out our new design. That's all from me. Then our friend Nazif will continue with the discussion and result. Thank you.
Let's move on to the results. So basically, this is our final product by using the CATIA software, and then insert to the idea maker by using STR file, which represented A as a bottle cup, B is a phone holder, and C is a hook. So basically, this is a 3-in-1 multi-purpose for rider to implement when riding for a long distance. So next is basically the testing from the idea maker application. So the first, as you can see, the first picture is the ABS setting parameter for 1.75 millimeter, and then the next one is the ABS setting parameter for 3 mm. And then the bottom left corner, which is a PLA setting parameter for 1.75 mm. And then the right bottom corner is a PLA setting parameter for 3 mm. So next is the results of between material ABS and PLA for 1.75 mm and 3.0 mm. So basically, the printing time for the fastest printing, which is a PLA for 1.75 mm, which provide for 8 hours and 8 minutes 50 seconds. That's for the output cost is much cheaper, which is $1.34. So based on the table above shows that the optimum 3D materials is PLA, which is a polylactic acid machine, due to the shortest printing time and also the lower labor cost of the output printing product.
Okay, at the end of this project, from screening and scoring, we find that most of suitable 3D printing is fused deposition modeling, and it can produce a complex shape, can be used as product testing, and it goes for sustainability. And from the simulation, we can get the time, mass, and cost of this project.